Welcome to Engineer Explains. In today's video, we will be discussing division as the opposite of multiplication. And so, in the previous video, we discussed multiplication. And we said in multiplication, you have, let's say, 5 times 3, which gave you 15, right? And so now we are going to be doing the opposite and say from this answer we are going to choose any one of these numbers between the two, but for now let's just choose 5. 15 divided by 5 is equals to 3, or 15 divided by 3 is equals to 5. So it's basically moving from 15 to get any of the number. If I divide by 3, I'm going to get 5. If I divide by 5, I'm going to get 3. So you basically get the idea. It is the opposite of multiplication now. This is saying if I have 15 apples, let's use our fruits analogy as usual. If I have 15 apples, let me do this. Okay, I split it into 3 times 5. 1, 2, 3, 4, 5. If I have 15 apples, I can either divide this by 3 and I will get 5, or I can divide by 5 and I will get 3. You get this idea. So it is basically the opposite of multiplication now. Okay, so let's just remember our fruit analogy. It is very important that we remember this. Thank you. And so in today's video, we will be mostly focusing on how division works in algebraic expressions. And so let's say we had 15 these apples again. So like we discussed in our previous videos, if we are talking about an apple, we are going to be using this x represented by the letter x. Okay, so if we have 15 apples and we divide it for 3 people, 15 apples dividing for 3 people, let's say the people are a group. Okay, and so it is represented by this string. 15 apples divided by 3 is basically 5 apples per person. That is what this thing is saying. Okay, so there's nothing different from our usual arithmetic going into our algebra. The only difference now is that we are keeping our x. And so here I use the division sign. Let me use the fraction so you can clearly see this. 15x divided by 3. What we did here is that we are working with our coefficients. And so just like how we did in multiplication, we said number 1, you multiply the coefficients, but now since we are doing the opposite, we are dividing the coefficients, right? Coefficients. And number 2, we said in multiplication we multiplied the coefficients and then we worked with the variables. We were multiplying the variables, but now we are going to be dividing the variables. Yes. And so remember, our variables are either x, y, z, or any other letter, or it can be x squared, y squared, z squared, or any other number. Okay, let's remember those are variables. Okay, and so yeah, those are the steps. Okay, first you divide the coefficients, then you divide the variables. It is a simple procedure. Okay, if you cannot divide the coefficients anymore, you divide the variables. Very simple. So here, let's say we had 15 here, right, divided by 3. You see, it is nothing scary about it, but this, you're just keeping the x. 15 divided by 3 is 5, and then you keep your x. Nothing different from multiplication. We're just doing the opposite. Okay, all right. So division is asking how many groups can we make? And so moving forward, like I said, this is number one, right? This is number one. We are going to be dividing the coefficients. Okay, and so that is what we're doing for number one, dividing the coefficients. We really have to understand how to divide the coefficients in algebraic expressions. It is always the first thing you're going to be looking at. Okay, so divide the numbers first. And here's our first example. So let's say we have 12 divided by 4. Okay, 12 dividing for 4 people. How many is remaining, or how much each are going to get? So if I had 12 apples, right? 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. So in total, this is 4 plus 4 is 8, and then plus 2 plus 4, I meant it is 12. So this row is unnecessary. Okay, you can count with me. 1 2 3 4 5 6 7 8 9 10 11 12. Okay, and so 12 divided by 4 is 3. You see that is 12 divided by 4 is 3, and then you keep your x. This is our fruit analogy. Okay, so first things first, separate the numbers if you really want to understand this. 12 divided by 4 is equals to 3. If you know this mathematics and it's working for you, perfect. If you are a bit slow, you can also use this. Perfect. Okay, and so in the end, you keep your x after you say 12 divided by 4, and then that is basically 3x. Okay, so that is your final answer. That is how we are dividing our coefficients. Let's do a second example. 20a divided by 5. 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. So you see, I had 5 going this way, and how many now do I have going this way? You count here. Okay, and then that is basically 4. So 20 divided by 5 is equals to 4. Okay, so that is how you can use your fruit analogy. Okay, so 20 divided by 5 is 4. You get that? And then since we said 20a divided by 5, and we got that 20 divided by 5 is 4, then you keep your a. Okay, keep your a. If you cannot divide a by anything, you keep it. Okay, leave it exactly as it is, and this is our final answer. Okay, so let's get into dividing the variables, because in the previous examples we were just dividing the coefficients. Okay, so from multiplication we know that x squared is equal to x times x, right? And if we are still confused about that topic, you can go back to our previous video and hopefully you get more clarification. And so division is cancelling the matching factors. In multiplication we said x times x, and we looked at the exponents, and then we said x to the power of 1 plus 1. But now what if it was x divided by x? Remember, this is still to the exponent of 1, and this is also to the exponent of 1. So this is going to say from this top x, not the bottom one. Okay, it is x to the power of 1, the one from the top right here, minus the one below here. Okay, so in multiplication we were adding, okay, and now in division we are minusing. This is division. Okay, so yeah, this is exactly how it is. So let me just make a different example. X to the power of 3 divided by x. Okay, So this is going to be x to the power of 3 minus 1. And your final answer would be x to the power of 2. Oh, and here, by the way, if we have x to the power of 0, that is basically just 1. Okay, your answer is 1. Reason being is that any number to the exponent of 0 is 1. So you can take 30 to the power of 0. This will give you 1. 5 million to the power of 0 is 1. So anything to the power of 0 is basically 1. Okay, so this is just saying if I have an x divided by an x, remember they have a coefficient of 1. Yes, they have a coefficient of 1 each, right? And so now this is going to cancel and this is going to cancel, and 1 divided by 1 is 1. Okay, so any number divided by itself is 1. And so if I have 30 dividing for 30, that is 1. Okay, so yeah, it is basically the same thing here. Okay, so I just wanted to discuss this as well. Okay, all right, let's go back here. So when we're dividing variables with the same base, so that is basically what we were doing in our previous example. We said x to the power of, so now let's just say m divided by x to the power of n. So this is a basic rule. So they have the same base. Base is x here. Base is x here. They have the same base, right? So you check, just like how we did it in multiplication, you check your base. If the bases are the same, okay, so now they are going to minus each other. So the top number, x to the power of m minus x to the power of n. Okay, so this is the same as x to the power of m divided by x to the power of n. All right, yes, I hope you get it. Oh, and by the way, any number, so let's say the number below here, any number that is below here, if you want to write it like this, you can say x to the power of negative n. You see what we did here, because any number that is below here is being minused, right? So if you have a number like this and you want to write it like this, okay, you just say x to the power of minus the exponent. Okay, yeah, I think you get it. Yeah, so let me make a different example. Let's say we had for example 15 divided by 30. Okay, so 15 divided by 30 is basically 1 over 2. Okay, so if you can put 1 over 2 in your calculator, it is 2 to the power of minus 1. Okay, it is 2 to the power of minus 1, and that will give you 0.5. As always, if you can put this in your calculator, you'll see. Okay, all right. So yeah, the powers subtract. So the upper power is minusing the lower power. Okay, so upper power minusing the lower power. So that is basically it. Okay, here's an example. X to the power of 5 divided by x to the power of 2. So let me just expand this. So we have x to the power of 5. 1, 2, 3, 4, 5, right? They are all to the exponent of 1, right? Okay, we just made it like that on purpose, because remember, in multiplication, we are going to add all of these and they were going to give us x to the power of 5, right? And here as well, we are going to add the exponents and they were going to give us x to the power of 2, because we have 2 of them here, right? And on the top you have 5 of them, right? So yeah, that is what we did on multiplication. But now in division we are doing the exact opposite. Okay, so we are gonna be canceling. Let me just start from this side. We are canceling, because remember, in multiplication we are adding, and now in division we are subtracting. So that is why I'm using the word cancel. Okay, so you see how many we cancelled here on the top and how many we cancelled on the bottom. So we cancelled the 2 that were on the bottom, and we cancelled the 2 that were on the top. Okay, so that would give us x to the x times x times x. You see how many x's are left here? You have 3 x's, so it is x to the power of 3, right? So this just proves that in division we are minusing the lower powers. Okay, so it is the upper power minus the lower power. So this is x to the power of 5 minus 2, right? You see it? So x to the power of 5 minus 2, what is 5 minus 2? It is 3. So yeah, it is always going to be like this. You can expand like this if you want a visualization of what is actually going on behind the scenes, or you can just use this. But then stick to this one. Stick to this one. It is very, very fast, because sometimes you'll be working with numbers like x to the power of 100 divided by x to the power of 55. So you know now that it is x to the power of 100 minus 55, which is x to the power of 45. You see now, you are not gonna make 100 x's and then you write on the bottom 55 x's. So this was just a visualization of what is going on behind the scenes. And so now, since you have that understanding of what is going on behind the scenes, you can now understand that it is the upper powers that are minusing the lower powers. That is basically what I am saying. Okay, so the exponents, yes, we are working with the exponents here for same basis, right? Remember that. Okay, same base. Okay, remember it is x and another x. Okay, so let's do this example. A to the power 4 divided by a. So now you have done even harder examples. This should be straightforward and simple for you. Remember a here, remember. Okay, a here is a to the power of 1. Please do not forget that. So it is 4 minus 1, okay, which is going to give us a to the power of 3. Okay, yes. Alright, so now we are dividing complete algebraic terms. What I mean by this is that now we are going to be combining the coefficients and the variables. Okay, so at first we were just saying, okay, hey, divide the coefficients, which were the steps we were using, right? Coefficients, okay, please forgive my spelling. And then number 2, we are dividing the variables. So that is what we did. And I started with the coefficients for a reason, and then I went to divide the variables for a reason. So I did that separately. But now we are going to be doing the complete algebraic term. Okay, so it is the combination of both the coefficients and the variables at the same time. Okay, so now we know we are dividing the coefficients first, and then 2, we are dividing the variables. So 12 divided by 4. 12 divided by 4 is 3, I believe. Yes. And then x to the power of 3 divided by x. So it is x to the power of 3 minus 1. So it is 3x to the power of 2. Yes. We can verify this for those who do not understand. 4, 1, 2, 3, 4, 1, 2, 3, 4. So here's our fruit analogy. Okay, so we have 12 apples in total, right? Dividing for 4 people, how many do each get? So this is just 1 person. Okay, so each get 3. You see, And then that is how we got this one. And then for those who do not understand the x's as well, we have 3 x's on top, and then we had 1 on the bottom. So this x is cancelling this x. And so how many x's do you have left? You have 2x. So it is x to the power of 2. Okay, I hope you get it. I explained this in different ways so you can understand it. So this was just the division of the coefficients. You can do it like this. This is just the behind the scenes, coefficients behind the scenes. Okay, and then this is the variables behind the scenes. Okay, so this is just for your proper understanding. Yeah, BTS, don't be thinking about Koreans now. Okay, we are we are doing mathematics now. This is not BTS. Yes, it's behind the scenes. Yes, so yes, just like how we did here. 12 divided by 4 is 3, and then x to the power of 3 divided by x is basically x squared, and then our final answer was 3x squared. It doesn't change when it's like this. Okay, all right, so let's do a different example. 15a to the power of 5 divided by 3a all squared. All right, so 15a to the power of 5 divided by 3a squared is dividing the coefficient. We are dividing, well, let's divide the coefficients first, and then yeah, we divide the variables as well. 15 divided by 3, it is 5. And then a to the power of 5 divided by a squared, it is a to the power of 5 minus 2. So that is 5a to the power of 3. You get it? We can expand this, but I believe you know it now. You can just rewind if you don't know how to do it, but let me just do it anyway so you can understand. We're dividing by 3. 1 2 3 1 2 3 1 2 3 1 2 3. How many do we have so far? We have 12. 1 2 3. We added 3 more, and now we have 5. Okay, so each person dividing by 3, how many each are going to get? Here you have 5. Okay, so that is how we got our 5 in this 15 total. You got 5 here. So this is the behind the scenes BTS of the coefficients. And then let's do the variables as well. So we had, okay, now we're working with a, so let me just write the a's instead of x. A times a times a times a times a. So we had 5 in total in the top, and then we divide them by 2. A times a. 1 2 1 2, right? So how many are left? You got 3. So it is a to the power of 3. You get it? I hope you do. And if you don't, you can just rewind. Okay? Yes. Alright, so we have a to the power of 3. So here is your final answer, 5a to the power of 3. Remember, you keep the a as it is, and you keep the variables, the coefficients as they are. Alright, so yeah, they were doing this, we were doing this using the division sign here. I want to highlight something. Okay, so in algebra you can either say 5x to the power of 3 divided by 3x. This is this sign here, this sign right here, it is a division sign. And 5x to the power of 3 divided by 3x, this here as well means division. Amongst many, you can also get that 5x to the power of 3 times 1 over 3x is the same thing as this, and it is the same thing as this, right? So I'm just showing you different ways in which division can appear. Okay, so I hope you get it. amongst many as well, because this is not a complete set. But I prefer for us in this course to use the fractions. Okay, so this is the fractions. This is standard form, standard or most common form, and then this is inverse. And you can also get what is this called? It is I think it's percentages. Yes, percentages and decimals as well. You can get those. So let's just in this course focus on fractions and the standard form. We'll get into inverse when we are no longer doing the introduction to algebra. Okay, so yeah, we will end here, but then of course we will touch on percentages and decimals, because they may be one of the same things, but I think for percentages, you are no longer involving x's, but in decimals you can involve the the letters which represent unknowns, and also in percentages as well you can involve the x's which are representing the unknown numbers. Okay, so let's get into algebraic fractions. So what do I mean when I say algebraic fractions? Let's say we had x plus 10 divided by 5. So this right here, let's rewind way back to the 3rd grade, or maybe you learned this late in 5th grade. Okay, so remember when we said x over 5 plus x over 5, and you had a common number below. When these two numbers were dividing by a common, so it is now basically x plus x all over 5, right? So there's nothing new here. So let's continue from here as well. X plus 10 over 5. So now we're just doing the reverse of what we learned in primary school. Okay, so it is now x over 5 plus 10 over 5, and so your final answer would be x over 5 plus 2. Okay, so it is basically us expanding this thing. Okay, or the other way around, where we have these and then we want to make it this way. Okay, so let's look at this example. X plus 5 divided by 3. This is x over 3 plus 5 over 3. Remember, common what's this thing? Denominators. Yes, common denominators. We can just write it like this. You can write it either way. So the entire expression on top is divided by 3. Okay, and so that is how we can write it in its singular form like this. All right, so let's do another example. 6x plus 12 divided by 6. This is 6x divided by 6 plus 12 divided by 6. And yes, we can continue when we have an expression like this. So this is, okay, let's cancel the coefficients first. Yes, can we cancel the variables? No. So 6 divided by 6 is basically 1. So this is just x. Okay, and then 12 divided by 6, that is basically 2. Yes, so yes, you see how you can also take this and get this if you use the proper numbers. So you just have to understand what you are doing, what you require, what the question requires from you. Okay, so I'm just showing you ways to do this. So you divide each term by the denominator. Okay, and then you add. Remember, we have a plus sign here. Okay, we have a plus sign, so don't neglect the plus sign. If you had a minus sign, so for example 6x minus 12 all over 6, what you would do is that 6x divided by 6 minus 12 divided by 6. Okay, please do not neglect the minus sign. So that is basically x minus 2. Okay, please don't neglect the sign that you have in the middle. Thank you. So that is just one of the common mistakes you may encounter. So mistake number 1 is cancelling terms instead of factors. So that is wrong. Okay, that is very, very wrong. Don't cancel the terms. You cancel the factors. So what I'm saying is that students might cancel the x. You can only cancel factors. Here's a correct example. 5x divided by x is equal to 5. Here, yeah, this is x over x plus 5 over x. Okay, that is correct. Okay, please don't make any sort of mistakes here. Thank you. Yes. All right. So mistake number 2 is forgetting exponent subtraction. So that is also a very common mistake that students make. Don't, please, it is very simple. You are dividing, or you are multiplying. You are working with exponents. Please, you are working with your exponents for algebraic terms. Okay, please, there's nothing hard about this. You are working with your exponents. But now if you are adding, why am I putting so many D's here? If now you are adding or you are subtracting, you are working with the groups. If you have an x like this, you minus it with another x that is looking like this. You are working with like terms, basically, like terms. Okay, so here in dividing or multiplying the algebraic terms or algebraic expressions, you are working with the exponents for those x's or y's. Okay, so you can get x squared or y squared or even more. Okay, so you are working with the exponents. Okay, by the way, when you are plusing, that is multiplying. When you are minusing, that is dividing. In adding or subtracting algebraic terms, you are working with the like terms. So x can minus x. Okay, so if you had 2x minus x, that is x, right? So if you had 3x squared minus x, this is final. It doesn't change. Remember why? Because these are not like terms. These are unlike terms. Okay, these are unlike, and therefore you leave them like that. Okay, so I wanted to make this distinction so you can never make this mistake. All right, so dividing or multiplying, you are working with exponents. Adding or subtracting, you are working with like terms. Okay, and so that is just a summary from our 3 previous videos as well. So we started with adding, then we went to subtracting, then we did multiplying, and then we did dividing today. And so you can check out our other videos as well if you missed them out. They will greatly help you. And so today we completed the 4 fundamental operations of algebra. We learned that division is the reverse of multiplication. We divide coefficients normally, while variables follow the laws of exponents as well. Okay, we touched up on the laws of exponents on the previous video. Now we have learned the language of algebra. In the next playlist, we will begin Algebra I, where we use these tools to solve equations, and understand how mathematics describes unknown quantities. Thank you for staying into this video. I hope you have a wonderful day. Thank you.